Hi, everybody. This is Dr. Grillo. So in this lab, we're going to kind of pick up where we left off with the previous lab when we created inter-VLAN routing and created sub-interfaces on a router. In this lab, we're going to work a little bit more on layer 2, and we're going to create what's called ether channeling between layer 2 switches. And ether channeling, in short, is you could take a switch backbone and you could take two physical links and logically treat it as one link. Thereby, if you have two links, you could double the throughput. So we'll go ahead and get started, and then we'll kind of look up and see what ether channeling exactly is. We'll also do something different. Instead of assigning IP addresses to the workstations, we're going to set up the Cisco router as a DHCP server for two LANs. So DHCP, Dynamic Host Configuration Protocol, is a server that automatically hands out IP addresses to DHCP clients. So let's just go ahead and get started. And we'll start by selecting switches in the bottom right. And we'll take two 2960 series switches and drag them into our workspace. Okay, and then from there, we'll create two links between these switches. This will be our backbone. So we'll use ports 23 and 24 for the ether channel. We'll create a connection on port 23 from switch 0 to port 23 on switch 1. And likewise, we'll create a connection on port 24 from switch 0 to port 24 on switch 1. So we have two physical links, and we're going to logically combine them into one link using ether channel. So let's go ahead and get started. So we're going to click on switch 0. We're going to go to CLI tab, and we're going to key in enable config T to get the global configuration mode. And we're going to use the interface range command on switch 0 to configure ports 23 and 24 simultaneously for the ether channels. So we do that by typing the command interface range or INT range F0/23 without any spaces -24. And when you do that correctly, your prompt should change to config IF. Okay, so I'm going to go into the preferences menu real quick. I'm going to go under options, preferences, go to font tab, increase the CLI size to 12 font, and I'm going to use white text with a background and click apply. Okay, and I'm going to click on switch 0 again. It'll be easier for you to see. Okay, our next step is to create a channel group, and we're going to start that by typing the command channel-group 1, and the mode is going to be on. Hit enter twice. You got to set up the ports for trunking. Now remember, we're configuring ports 23 and 24 simultaneously with the interface range command. So we type switch port mode trunk, and from here we create our virtual interface, our port channel. So it's going to be interface port channel 1, and again we're going to type switch port mode trunk. Okay. And that creates the logical ether channel by combining ports 23 and ports 24 into a virtual port channel 1. And we're going to type exit to get back to global configuration mode. Now we're going to repeat that same process on switch 1. So we're going to click on switch 1 and go to the CLI tab. And we're going to type enable config T. And then we're going to use our interface range command, FA0/23 to 24. Oh, got the range command. See, when you make a mistake, you'll get an invalid input detected at marker, and so you just need to key in the command correctly. And notice your prompt will change to config-if-range. So we're going to type the command channel-group1 mode on. We're going to type switch port mode trunk. And we're going to type interface port channel 1. And we're going to type switch port mode trunk. Now the protocol that's used in Etherchanneling is called LACP protocol. And if you don't specify a protocol, that's going to be the protocol that's enabled by default. So that's the Etherchannel protocol that we're using. So right now, we've configured the Etherchannel link, right? We had two 100 megabits per second separate links as our backbone. And we've combined that virtually into one logical link, speeds up to 200 megabits per second. Okay. Now we're going to do some other things on the switch. We're going to create our VLANs. So the commands are the same. And so to do that, we're going to key in the commands interface range FA0/1 through 5. We're going to configure ports 1 through 5 for VLAN 5. And we're going to hit enter. And we're going to type switch port mode access. And then switch port access VLAN 5. Okay. Now, we're also going to configure port security for ports 1 through 5. We're going to type in port-security, switch port-security, hit enter, hit the up arrow, right, for command history recall, hit the space bar, type max1, and then hit the up arrow, delete max1, type MAC address sticky, and then we'll specify the violation mode, which will be the shutdown. Then we're done. So what we've done in these series of steps is we've taken ports 1 through 5 on the switch and assigned them to VLAN 5. Okay. And then from there, on ports 1 through 5, we created port security. Now we're going to configure ports 6 through 10, and we're going to assign ports 6 through 10 to VLAN 10 and also configure port security. And we'll be using the up arrow key a lot, and it's a way of actually speeding up the process in your configuration. So we're going to start off by typing interface range FA0/6-10, and this is ports 6 through 10. Okay, now watch what I do with the up arrow. 1, 2, 3, 4, 5, 6, 7. Right, 7 times. Switch port mode access, hit enter. 1, 2, 3, 4, 5, 6, 7. Change switch port access VLAN 5 to VLAN 10. Hit enter. 1, 2, 3, 4, 5, 6, 7. Enable port security. Hit enter. 1, 2, 3, 4, 5, 6, 7. Right? Maximum MAC addresses that can be associated with that port is 1. Hit enter. And 1, 2, 3, 4, 5, 6, 7. MAC address sticky. And then finally, specify the violation mode of shutdown. Okay. And that completes everything we need to do on this switch 1. Okay. So we're going to minimize this window. And if you want, you can rename switch 1 to switch B. And we'll name switch 0 to switch A. I'm not creating host names. I mean, you're more than welcome to create host names and also create the line console password, create the enable secret password. You could do SSH on these switches from a previous lab if you wish. And so that's kind of a challenge. If you wish to incorporate everything from the previous labs into this lab, that will be fine. Okay, so that would require you going back to that lab 2 that we went through earlier. Next step is to configure switch A. It's kind of the same process, and I'm going to show you a trick. Now, the commands we've typed are going to be identical to what we typed on switch B. Because again, on switch A, we're enabling ports 1 through 5, and assign it to VLAN 5 and create port security. And then on ports 6 through 10, we're going to assign that to VLAN 10, and we're going to enable port security. I'm going to show you a little, it's a trick. You can open up a notepad document, for example, and click on notepad. And sometimes administrators, technicians keep their configuration files on notepad, and you'll see why in a second. And I'm just copy and pasting that, and I'm going to delete all the prompts. So I'm just going to be left with the commands. You can follow along. Okay, this note that we get that the VLAN does not exist creating VLAN 5, you can delete that. Hit the delete key again. And I've done this before. If I got a key in identical configuration files, and normally you can't do it with IP addresses because you would be assigning identical IP addresses, if you did this on a router, or if the port assignments were different for the VLANs, right? This would probably be more difficult to do. But when you have identical configurations, this is really helpful to do. And one more, and that's what we're left with, right? Just got all the notes, all the prompts, and left solely with the commands. I'm going to highlight that. I'm going to select copy. I'm going to go back to packet tracer. I'm going to go back to switch A. Now you got to make sure you start off in the right mode. So you got to be in global configuration mode. I'm going to right click and go paste, and I'm going to hit enter. Okay. And so that kind of speeds up the process of creating that identical configuration on another switch. I'm going to minimize the switch window. So again, we've created the Etherchannel. Now instead of 100 megabits per second on 2 separate links, we got one virtual link. That's our backbone that can carry traffic up to 200 megabits per second. And then we've also assigned ports 1 through 5 on both switches to VLAN 5, and ports 6 through 10 on both switches to VLAN 10. And we've assigned all the ports port security. Okay. Now notice we haven't done anything with ports 11 through 23. Okay. So that's just something to keep in mind. Okay. Next step, right? We're going to configure our sub interfaces for VLAN 5 because again, you're going to need a default gateway for those sub interfaces. We're going to create a trunk link from the switch to the router. And then from there, we are going to create a DHCP server on the Cisco router for VLANs 5 and 10. And then you'll see how easy it is when you start connecting PCs to ports and their DHCP clients and how they can automatically grab IP addresses. So what we'll do is we'll click Network Devices. We'll select the 2911 series router, drag it up to our workspace, select the connections icon, click the copper straight through cable, click on switch A, and what we have to do is select the port not in use, right? So again, ports 1 through 5 are for VLAN 5 and ports 6 through 10 through VLAN 10. Ports, you don't see ports 23 and 24. Those are used for our Etherchannel backbone. So we're going to select Gigabit Ethernet 01. Point your mouse over router 0 and select Gigabit Ethernet 00. Okay. Our next step, we got to go back on the switch and configure the Gigabit Ethernet 01 link on the switch as a trunking port, because as you recall, a trunking port is used to carry traffic for multiple VLANs. And we did it with our Etherchannel as well. This is our backbone. And so we're going to click on switch A, and we're going to type INT G01, and we're going to type switch port mode trunk and hit enter. Now we're going to type end, and we're going to save our configuration file with the copy run start command. Okay, and we're going to save the configuration file on switch B. Type end, hit enter twice, and key in copy run start. Hit enter twice. Okay, that completes the configuration on both switches. Our next step is to configure the sub-interfaces and the gateway addresses for router 1 for VLANs 5 and 10, and then we'll configure the DHCP server. So we're going to click on router 0, click the CLI tab, key in no, hit enter twice, type EN, hit enter, type config T, hit enter, and we're going to go to that physical interface, if you recall from the last lab, interface G0/0, hit enter. And the only thing we do with the physical interface is we turn it on with the no shutdown command and hit enter twice. And we'll create our first sub interface for VLAN 5. We'll type INT G0/0.5, hit enter. Okay, hit enter twice, and your prompt will change to config sub if, right? We're going to remember, if we call from the last lab, there's two kinds of trunking protocols used, ISL, which is Cisco proprietary, but the more common one, the open source, is .1Q. We're going to set the encapsulation, .1Q, hit the space bar, and we're going to specify that this interface, sub-interface, is for VLAN 5. So you key in a 5 and press enter. Now we're going to key in an IP address, and we're going to use the similar IP addressing scheme that we used in the last lab. We're going to key in IP address 10.0.5.1, 255.255.255.0, right? Where the first 3 octets represent the network address, right? And we're using the third octet to identify the VLAN. And then we press enter. Okay, now you can add descriptions later if you wish. You could add it now, pause the video. And that's the same thing, on the router. Configure the host name, line console password, the enable secret password. You can go ahead and do that, and you can pause the video at any time and then go back to where we were and kind of follow along. Or you could do it at the end. Okay, now we're going to hit the up arrow once, twice, 3 times. And we're going to delete the 5 by hitting the backspace key and type 10. And we're going to create our second sub interface and hit enter twice. Now we're going to key in the IP address, hit the up arrow 2 times. We're going to set the encapsulation first. So you're going to hit the up arrow actually 3 times, and you're going to delete the 5 and key in a 10 and press enter. And you're going to hit the up arrow 3 times, position your cursor right after the 5, right? Hit the backspace, type 10, and hit enter. So again, 255.255.255 network mask says that the first 3 octets are the network portion of the address, and we're using the 10 and the third octet to identify the VLAN. Okay, So that creates the sub interfaces. Okay. Our next step is to create, and this is something we haven't done yet, using a Cisco router as a DHCP server. So we're going to go back to global config mode by typing exit. And we're going to create our first DHCP pool for VLAN 5. And the command to do that is IP DHCP pool. And if you hit the question mark, it kind of tells you what to do next. It says you give the pool a name, right? Well, we're going to call it VLAN 5 because this is going to be a DHCP server for VLAN 5 with the network address of 10.0.5.0. Press enter. And notice how your prompt changes to DHCP-CONFIG. Okay. First thing you do, you have to specify the network. So you type network 10.0.5.0 space 255.255.255.0. A DHCP server will also tell the DHCP clients the address of its default gateway. And so the command to do that is default router 10.0.5.1. It's the sub interface we just created for the G0/0.5 interface. And we hit enter. Now, we don't have a DNS server set up in this lab, so domain name service, right, resolves host names into IP addresses. So when you type www.myfavoritewebsite.com, right, on your browser, that goes to a DHCP server. It gives you the IP address, and then you go out with that IP address, right? You do DNS queries. And so even though we don't have one, we could specify one. Let's just pretend we had one, and we'll type DNS server, and we'll type the same IP address that's assigned to the sub interface on the router for VLAN 5 and hit enter. Okay. Second step is create the second pool for VLAN 10. So we type IP DHCP pool. The name we're going to give it is VLAN 10, and we're going to press enter. And we're going to specify the network. We're going to type network 10.0.10.0, 255.255.255.0. Hit enter. The default router, which is the gateway for VLAN 10, which is the sub interface that we created, will be 10.0.10.1. And then the DNS server will be 10.0.10.1. Okay, so that sets up DHCP. What you normally want to do when you're setting up a DHCP server, you want to exclude some addresses because there are going to be devices on your local area network that cannot be DHCP clients. They can't have their address changing all the time, right? Because then your computer wouldn't be able to find those devices. So devices like servers and printers, right? Those are going to have static addresses. And so you want to have, even though we've got up to 254 addresses available, we want to reserve about 10 IP addresses in each VLAN in the event we want to create, add printers and servers to our VLANs. So we do that by typing exit. This is done in global config mode. And we type IP space DHCP space exclude it. Now, here's a trick, right? And there's a lab that shows you how to go through the process of correcting your mistakes, how to speed up the configuration. If you hit the tab key, it fills out the rest of it for you, right? And so it's the excluded addresses. We're going to exclude addresses .1 through .10 for VLAN 5 first. So we type 10.0.5.1. That's our starting address. Hit the space bar, and we're going to type 10.0.5.10, which is our ending address. And we're going to hit enter. And we're going to do the same thing for VLAN 10. IP space DHCP, hit the letter E, fills out and hit the tab key, fills out the rest of it for you, and type 10.0.10.1. That's the starting address. Hit the space bar. 10.0.10.10, which is the ending address. Okay, and that completes the configuration on the router. So what we're going to do is we're going to type exit. We're going to save our configuration, copy, run, start, and hit enter twice. Now the easy part begins. We just start adding PCs to our VLAN. I'm going to minimize the router configuration window. And we're going to take some end devices. We're going to click on end devices. We're going to select PC. And we're going to use a copper straight through connection. We're going to select fast Ethernet and connect it to any port. It could be any port. This computer is going to be assigned to VLAN 5. So ports 1, 2, 3, 4, 5. It doesn't matter which one. I'll just select port 4. Okay. And then I'll take another PC. I'll click on end devices. I'll take another PC. Click the connections icon. Select copper straight through cable. Select fast Ethernet. And then I'm going to click on the switch. And any ports 6 through 10 are assigned to VLAN 10. I'll just select port 8. You could select port 7 or port 6 or port 9 or port 10, right? They all belong to VLAN 10. Likewise, on PC 0, any ports 1 through 5 will be fine. So I'll relabel these. I'll just call this PC1-VLAN 5. Hit enter. I'll call this PC2-VLAN 10 and hit enter. Okay. Now I'm going to go on to switch B. I'm going to select the PC. Excuse me. So I'm going to take a PC and click the connections icon. Select copper straight through cable. I'm going to select fast Ethernet. And I'm going to connect to any port from 1 through 5. I'll just select port 1 this time. And I'll repeat the process. I'll select end device, select the PC, click the connections icon, the Thunderbolt, select copper straight through cable, click on PC, select fast Ethernet, and I'll just click on port 9 this time because that's in VLAN 10. And I'll relabel these. Okay, so this will be PC3. That's also in VLAN 5. Enter. And this will be PC4. Oh, I don't know how I got that. There we go. I clicked on the physical tab there by accident. I'll click on PC3. I'll call it PC4 VLAN 10. Okay. Now I just need to get the computers, turn them into DHCP clients, and they'll automatically grab an address from the DHCP server. So if I click on PC1 in VLAN 5, click the desktop tab, select the IP configuration window, and I change a static address, which means manually assigning an IP address, and select the DHCP button, and wait a few seconds. Notice I grabbed an address from the DHCP server, right? Now 1 through 10 are excluded, so it gave me the next available one, right? This is a PC in VLAN 5, so 10.0.5.11. Notice the network mask, and notice I got the address of my default gateway and DNS server, okay? And I'm going to close the PC1 VLAN 5 window. Now this PC2 is in VLAN 10, right? So it's going to get a different address. It's not going to get a 10.0.5. It's going to get a 10.0.10 address. I click on PC2, select the desktop tab, select the IP configuration window, and click the DHCP button. Okay. Notice the address, 10.0.10.11. Again, Addresses 1 through 10 are excluded. Notice the address of its default gateway and the address of its DNS server, right? The default gateway addresses are the sub-interfaces we created on the router for the respective VLAN. And as you can probably guess, when we do PC3 on VLAN 5, it's going to get a 10.0.5.12 address because this one had a 10.0.5.11 address. So we're going to click on PC3 and VLAN 5, go to the desktop tab, go to the IP configuration window, and select the DHCP button. And it's got a 10.0.5.12 address, right? It's got the default gateway address, and the address of the DNS server. Okay. One more we need to do, PC4 and VLAN 10. We click on it, click the desktop tab, go to the IP configuration window, and select the DHCP tab. Okay. So right now, you got full connectivity. You have a high-speed backbone Etherchannel link going on between these two switches right here, right? We're doubling the throughput from 100 megabits per second to 200 megabits per second. And so we can actually test our configuration. If we know the address of the PC on VLAN 10, PC4, it has an address of 10.0.10.12. We can go to this PC1 on VLAN 5 and try to ping it. Go to the command prompt and type ping 10.0.10.12. And it may take a second for the link to come up as that MAC address passes through the switch for the very first time. And as you can see, we have connectivity. If you want 100%, just hit the ping command again, hit the up arrow, and press enter. So again, as a reminder, the traffic flow, right? We're not going from here to here. We're going from here for a sub-interface gateway, right? And then down to the VLAN 10 sub-interface, down to this trunk link, over the high-speed ether channel, and back over to PC4. Okay, so this concludes the lab. And what I would recommend you do is if you're going to add additional commands, then, for example, if you were to configure the, enable secret password, I want to do the commands. I want to practice these commands and the line console password. For example, you did all that. Just remember to save your config file. Okay, we have already saved them. Copy, run, start. Sometimes I have a poor memory, and I will actually save these again because I honestly don't remember if I saved it or not. And I'll just resave the config on the router and two switches. Copy, run, start. Hit enter twice, okay? Now again, the only thing you would need to do after that is save the file. So you just go File, Save As, right? And you type in your first and last name. So John Grillo. I'm gonna name this IT 2280, and we'll just call this Lab 3. Okay, and you could save it to your desktop tab, and you could upload it in the course room if it's part of the assignment requirements as far as the grade is concerned. So while I'm developing these labs, right, for these courses, as you know, Capella, sometimes the labs are just optional activities, and sometimes the labs are part of the grade. And so I don't know that yet. I'm just creating the lab. So even if the labs aren't part of the grade, this is where most of your learning is going to come in. Now, anytime you don't understand something, you want to know what Etherchannel is, I encourage you to use Google, right? So go to google.com and just simple, what is Etherchannel, right? And, click on Wikipedia and it tells you it's a port link aggregation used primarily on Cisco switching. It allows grouping of several physical ports into one logical port. So you can read about anything. What is DHCP? I explained it. And you get an AI overview. It's a network protocol that automatically assigns IP addresses and other configuration information, such as the default gateway and DNS server, to devices when they connect to a network. This allows devices to use network services like DNS, network time protocol, and communication protocols based on UDP or TCP. So if you don't know what UDP and TCP is, right? UDP, um, your common internet protocols for like web access and emails use TCP, which is called connection oriented, because there's a concept of sequencing and acknowledgments. So when you connect to something, you agree on a window size on how many packets to send to you at a time, and then when the end device sends you packets, you send an acknowledgement that you received the packets, and it sends you more, and you send an acknowledgement, and that process goes on until the transaction's complete. Well, UDP doesn't have that overhead; it just sends the information, right, without the sequencing and acknowledgments. And you say, well, TCP is better. Well, some some network protocols and some network services, for example, video conferencing, right, and video streaming, large chunks of data, can't have all that overhead, right? And so look at TCP as almost sending a letter through the mail via certified mail, right, and getting a return receipt. And UDP is just like first class. You stick a stamp on an envelope and you send it through, right? And you hope it gets there, right? Vast majority of the time it gets there. You really don't even have to worry about it. But if that letter ever to get lost, there's no way of tracking down a first class mail package, right, without tracking. So you know how the post office works. So um, in short, this concludes the lab. And if you have any questions, please let me know. Thank you.